Let's talk about a shaper. What is a shaper? Well, a shaper is, well, it's the big brother to the router. Okay? It can cut miles and miles and miles of trim without ever tiring out. You can set it up for doing raised panels for doors. You can set it up for cutting profiles. You can set it up for making stile and rail cuts. It doesn't matter. It's a very versatile tool. But as you can see, it's a very, very dangerous tool in the sense that there's a lot of open room here. Your hands can come into contact with these blades, and in an instant, your fingers will be gone, your hands will be tore up. That's why it's so important that you understand that when you're using any type of machine like this, especially a shaper, that you use some sort of a hold-down device. This is a power feed, okay? It has wheels on it, and it runs the wood or the lumber across the cutter. You could use a feather board. A lot of these machines come standard with hold downs and feather boards. What the object is to keep your hands away from that spinning blade. Now, to do curved work, I'm going to try and demonstrate this to you. Let's say that I wanted to put a detail on this edge. I want to put like a raised panel curve on this. This might be a cathedral panel or an arch panel of some sort. Well, I need what's called a bearing, okay? And a bearing goes on top of the cutter, and it rides on top and it spins, and what it does is it stops me, the worker, from pushing the lumber too far over the top of the cutter. So in other words, I can only go so far, okay, because I'll run into that bearing. Now that's not the only thing that I can use to stop me from going over the top. I could use a guide bushing as well. A guide bushing doesn't spin, it just sits there and I rub against it, otherwise known as a rub collar. This machine requires a special lock washer. You can see that there's a piece of metal here, and this piece of metal is called a spindle. This particular spindle happens to be 1 1/4 inch bore. Well, the way this works is this goes over to the top. A spacer, well actually the bearing goes on top of the cutter, followed by a spacer, followed by a lock washer, followed by the nut. Okay? So what I'll do is I need to go around to the back of the machine, lock the spindle, and I'll take this off and I'll show you the inner workings or the dynamics of this spindle of this cutter. Okay? So just a minute. One more thing before I stick my hands down in there. Any type of power equipment that you're getting ready to adjust, up, down, take off cutters, whatever, I always like to turn off the power. Well, especially with this powerful beast, I want to make sure that I turn it off so that there's no chance that while my hands are in there on the inside of that machine that thing can turn on. Okay? So always turn off the power before you make any adjustments. Alright, what I'm going to do is I'm going to go ahead and take this nut and pull everything off for you. Then I'm going to put it back together. We're going to talk about spindles. We're going to talk about the bearing and the lock washer. I always like to talk about things and let the students see them. So remember, anytime you're using this, righty-tighty, lefty-loosey, okay? So I'm going to put the wrench over here. And these things are tight, and they're tight for a reason, so they don't come off while you're using them. Okay? So I got the tension loose. Now I'm going to undo this. The nut's coming off. Underneath the nut will be the lock washer. That's important. Okay? Without that lock washer, while this thing is turning, it may loosen this nut, fly off, and then all of a sudden you have a shaper flying across the shop or in your lap. That's not very nice. I wouldn't want to be in that position. Okay? So here is the lock washer. Notice it's special. It has 2 teeth that slide down in this groove. Lock washer, spacer, and bearing. Okay, now these are machine fit. They're not just going to be sloppy in here, so try and get these off. Okay. Here's the bearing. You'll see that when it's on there, it spins. That's its job. It's for cutting curved work or shaping curved work. This is a guide washer or spacer washer so that this bearing doesn't sit down and break the carbide. And this is a raised panel cutter. Okay, notice that it sits on the spindle here. If you take a look at that spindle, it's just a solid piece of metal and it's threaded. And notice it sits like this and not like this. Okay? And it sits in this configuration. It's what's known as bottom cutting. In other words, the piece of lumber goes over the top and the cutter is on the bottom. Some places may take this cutter, we won't in our shop, turn it upside down, raise the height of the spindle, and try and run, let's say, run a piece of lumber between the cutter, the bottom of the cutter, and the top of the shaper. In other words, if I could do this, I would have something that would be going like this. Cutter's on top, lumber's between the bottom of the cutter and top of the bed. That's dangerous. What happens if this has got a slight bow or warp to it? Well, this machine is a lot stronger than I am, and it's going to kick this thing out, possibly pull my hands into it. Also, where's the cutter? The cutter's spinning at about 9,000 RPMs, and if it's on top, where's the cutter and where are your hands? Okay? It doesn't take a genius to figure out that your hands are in much more danger being close to a spinning cutter that's above the workpiece rather than a cutter that is below the workpiece. Okay? So this is how we do it. This is how our router tables are set up. This is how our shapers are set up. The cutter is below the workpiece. Now I'll go ahead, put this back on, and it's simply done like this. Remember, if you ever do this, make sure you check with your instructor. Make sure he or she is aware of what you are doing. You may want to change this raised panel cutter out for an Ogie or for a Coven bead. All these cutters all have 1.25 inch bore, and they'll all fit over the top of that spindle. Just like routers will accept all different types of router bits. But for this particular instance, I'm going to put this back on, followed by my little spacer, followed by my little, that was my washer, my other spacer. Whoops, I forgot to put my bearing back on. Make sure that gets lined up nice and tight. It slides down there, followed by this, my spacer. And now my lock washer has to go in these grooves. Sits down, and I put this nut back on just the way I came off. Okay? Righty-tighty. And that's nice and snug and tight. Again, now I have to go back in the back of the machine, unlock the spindle, and then we'll go ahead and demonstrate. I'm going to go ahead and demonstrate this here, but I need to talk to you about the margin of safety. Margin of safety on this particular piece of equipment is the same as on the router tables, the table saws, the joiner. It's 4 inches. It means 4 inches in front, 4 inches in the rear, 4 inches to the front of the machine. It's 4 inches all the way around. That means, so if you have something that is too small, where your hands would come within 3 or 2 inches, you need to come up with some sort of jig or fixture that's going to hold that piece so that you can shape it. This piece that I'm about to run will allow me to maintain my 4-inch margin of safety and still be able to complete the desired effect that I'm after. Okay? Also, does it really matter which way we feed material into this? Well, let's think about that. if this machine has a reverse and a forward on it, it can spin this direction or it can spin this direction. If I come from my left and this machine is spinning this direction, it's not going to cut very well, but it's also going to take my material and want to throw it. So I want to make sure, like always, that these cutters I'm feeding into or against the cutter. Does that make sense? As this spins this way, I want to come this way. So direction of cutter is important. All right? So let me get on my hearing protection. And I'll go ahead and I'm just going to demonstrate or try and give you an idea of the importance of a rub or a bearing, okay, and what can allow you to do. So here we go. I'm going to always check and make sure that this thing is spinning this way before I start actually working on it, okay? Make sure I got my workpiece in my hand. Turn it on. Oh, I didn't turn the power back on, did I? So I turn the power on. Let's check the direction of the rotation rather. And it's going this way, so I need to come this direction. So I turn this on. Now I'm going to shape this side right here. So I come in here, I touch here. Now, I created a lot of dust, and I did that simply for demonstration so that you guys could hear me through this process. This is what it did. This is like a raised panel. This is the profile that I'm after. Now, some of you may be saying, well, why didn't I have some sort of hold down on this? If I was doing this out of solid red oak or maple or something really hard and this was big, absolutely. I like my hands. I need them to make a living. So I could have definitely had some sort of fixture that held this in place. But notice that I just didn't walk in here and go like this. What I did is I came off of something that was stationary, and then I rotated into the bearing, and then once it started cutting, then I went all the way against it. Okay? Again, any student that is doing this type of work is going to have permission from their instructor. The instructor is going to need to come over and check their setup to make sure that everything is correct. Okay? Now, what I do in my class, I use this cutter here specifically for doing raised panels. This is a red oak raised panel, and I'm going to attempt to raise the end. Whenever you're cutting lumber, or you're putting a profile on the edge, you always want to cut the end grain first, okay? Shape the end grain, then do the edge grain or the long grain, okay? These soda straws will break. As I come across here, they will break off because they're not supported. But when I rotate it this direction, that'll take any of those splits or tears will be fixed as I shape the long grain. I'm going to demonstrate using the power feed this time with this setup, because it's very safe, it keeps this very flat, and it's very consistent, okay? So let me get set up and then I'll show you. Okay, I'm about to run this panel through this piece of solid red oak, and I'm going to try or demonstrate raising the edges. Anytime you use a hold down device such as a power feed, featherboard, any of that stuff, what you want to do is you want to make sure that the cutter will clear rollers, the fixtures, the hold downs, whatever, and you simply use a piece of wood or a pencil or something, and it's clear, okay? Never ever would I want to stick my hands in there in case somebody came by and turned it on and my hands are in there. Okay, so use a pencil, a stick, or something, something wood hopefully, not metal in case something does go on. get clicked on. But you want to protect your equipment. You want to make sure that you're not going to have any surprises when you turn on the power. Okay? So what I'm going to do is I'm going to turn this power feed roller on. I've checked the height of the rollers to make sure that I have about, an eighth of an inch lower than the top edge of this, so that I get good down pressure, and it'll feed it all the way through the process. That bearing that's in there will also help to stop this panel from going too far in. If you'll notice, this is kind of kicked off at an angle, and the reason it is that so it keeps it tight to the fence through the whole process. And that bearing needs to be there for this as well. So let me go ahead and turn this machine on. Again, it's going to make some sawdust. So normally you'd have the fans on. Right there. And there's that tear out we talked about right there. Okay? Those soda stars got broken. So now I'm going to run it this way and this way. Some more tear out right there. Okay? Okay, so now you can see what we have is a panel that's been raised on all four sides. We would need something to stick this into, like a stile or a rail with a match set of stile rail cutters, which we happen to have over here, and I'll demonstrate those to you. Okay, so come follow me over here. And what I'm going to do is I'm going to create the male portion of this joint. Okay? And this is something that you need to understand. When you are doing anything at the end of a board, especially a narrow board, well, it wouldn't make sense for me to come up here and try and do it this way. I've got very little support. It's a lot longer than it is wide. So what I need is the use of a miter gauge. And that's what I have here. I have a miter gauge that comes with this machine, and it rides in this groove, and I have an auxiliary fence that I've mounted here to keep it tight right here. And there is that right here is that rub bearing that we talked about. It's a bushing rather instead of a bearing. This does not spin or like that bearing does. It rides up against it, and what that does is it ensures that I have the proper tenon length on this piece of lumber. So I'll go ahead. I need to make sure, again, that these are going to be spinning towards me since I'm on this side. So I'll go ahead and check that. And I can already tell you that they are. But I'm going to make sure, I'm going to check. And they are spinning towards me. Now, the margin of safety on a shaper is what? It's 4 inches. So that means I can't put my hands here. I have to keep my hands here. 4 inches right there. So I keep my hands here, and I'll be fine. Here. And that's the type of joint that it makes, or configuration. Now this is called the cope cut, okay, of a cope and stick set of cutters. Now we're going to go over to the other shaper, and I will be using the power feed, which is already set up, to create a groove here, and I'll need to create a groove here as well. And I didn't mark this, but I should have marked this with an X, and the X always goes down. And if this is MDF, so if this is my good side, I'd mark this with an X, and it goes down. I did mark the panel, however, with an X, as you can see, and that's when I ran it. The good side was down. Okay? So make sure that everything's out of the way. And I'll check my height, my power feed. It's good. I'll turn my power feed on. I'll check to make sure that nothing is in here. Just a minute. So I got this stick. I'm going to make sure that everything's fine. And it is. Turn it on, check the rotation, turn it off. Because accidents happen when you take for granted that everything is working, or, well, it wasn't that way when I left. So you always check, get in that habit, okay? You always wish you would have. All right, so the curved part of this joint, I always know, needs to go down. I should have an X on here. I would have an X. The same thing with this one. It doesn't have anything. But we're going to create a joint to where we can interlock them together, and then we can stick this panel in. All right? So I'll run this first piece here. Make sure this is on. Okay, we got the curved part. It's going down. Notice my hands are going to be here. The power feed is going to grab it. I'm standing off to the side. Once the machine grabs it, I let it go. Okay? And that's what it makes. It makes this type of a joint. You can see the groove, which will eventually house this, like so. Okay? Now, we also need to just do this as well. Come here. Okay. Creates a lot of dust when the fans aren't on, let me tell you. So we have this. We have the cope cut and the stick cut. And then we put these two together. We create the bottom portion of a panel. It's a nice fit, panel frame. And then, let's see if I can do this here. This would go in here. This would go in here. And of course, you'd glue, whoops, let me get that in there. There we go. And you could see how this would be the start of, whoa, come on, baby. The start of making a raised panel door. And you don't just have to make doors out of this stuff. Look, I could change these cutters out of the way. I could change these cutters. I could run cove and bead material. I could run flush trim cutters. I've got all types of options with these. Okay. The main thing is that you don't want the shaper cutter to be on top. You always want to do a bottom cut. You never want to have your hands within 4 inches of it. Any special cuts, curves, or anything like that, you always need to have your permission, or the instructor's permission. You want to use a power feed, a hold down, some sort of device to ensure the safety of your fingers if you're only cutting one board. Okay? And, you know, if you're, like I said, if you're shaping the ends of narrow boards or something like that, a narrow board like this, well, you certainly can't come up here and try and get that done this way. You must use some sort of support like a miter gauge. You have to use it, maintaining your 4-inch margin of safety. Also, you want to make sure that the cutter is always spinning towards you, that you're not moving in the same direction that the cutter is spinning. You need to make sure, again, all these shapers have a nut that goes on top, followed by a lock washer and some sort of spacer. It's just set up for the type of joint that it's going to cut. And again, if you have any questions, if you're unsure at any time about anything to do with the shaper, you always want to check with your instructor. Okay, it doesn't take that long, and your instructor can probably shine some light on some of these areas that you may feel nervous about. Okay, it's a great machine again, but you can see the risk of getting your hands cut in there. So again, make sure you always watch that 4-inch margin of safety. All right, one last thing that I need to mention to you. You saw how powerful these machines are. This is a 5-horse, it's a 7.5. It doesn't matter. They're very powerful. They're more powerful than you and I are. Okay? So the lumber you choose, make sure if it does have any splits in it that you don't use it. Splits, knots, screws, staples, any of that stuff, you don't want to use that. Okay? Especially things that have splits or loose knots in it, because somewhere through the process that split might all of a sudden no longer be a split. It might become a break, and then that machine can throw pieces of wood violently throughout the shop and hurt not only yourself, but it could possibly hurt somebody else that's in the shop. So remember that. Loose knots, okay? These cutters catch those knots. They can fling them out. They can hit you in the arm, the eye, the ear, hit somebody else working. Nails, screws, any of that stuff. Make sure the integrity of your lumber is good quality, solid lumber, okay? And make sure, again, I can't stress enough to keep your fingers 4 inches, at least 4 inches away from these spinning blades.